In this problem, we're being asked to consider the area that's formed by the intersection of these three curves: y equals x cubed, y equals x plus 6, and y equals negative 1/2 x. So if we begin with the graph of these, y equals x cubed roughly looks something like this. X plus 6 would be this line, and negative 1/2 x would be this line. So at some point these curves intersect. We need to find the points of intersection, and that will help us get started. So we need to figure out what this point is and what this point is. So y equals x plus 6 and negative 1/2 x intersect at negative 4, 2, and x cubed and x plus 6 intersect at 2, 8. So my figure runs from the x value is negative 4 to 2. Now, the thing to notice though is really this figure is composed of two things. First, there's the area that I'll outline in red, and that's between the line x plus 6 and negative 1/2. And then there's also the area that I'll have in green, going from x plus 6 to x cubed. So even though I want one full area, to calculate it I'll need to deal with both areas in a sense independent of one another. My integral for the area in red will be going from negative 4 to 0, because that's the x values that's bounded by. And for our area under the curve, we always want to integrate the upper curve minus the lower curve. So in this case, we need to consider x plus 6, the upper curve, minus negative 1/2 x, the lower curve, dx. And what this means is I'm going to find everything from x plus 6 to the x-axis, and then subtract everything from negative 1/2 x to the x-axis on the interval negative 4 to 0. And that will give me the area in red. See if you can come up with the area in green. Hopefully you pause it and we're able to. We can see in our picture that the area in green runs from 0 to 2 on the x-axis, and it's always the area underneath your upper curve, so x plus 6, minus your lower curve, in this case x cubed, dx. These two expressions will give us the area of the red and green portions of my entire object, and their sum will be the area of the entire thing. If you're proficient with your calculator, I would encourage you to practice integrating this with your calculator, although you can do it by hand. Once you've integrated these and you've done this properly, you should end up with an area of 12 for the portion in red, and an area of 10 for the portion in green, which means the total area is 22.